about compound inequalities. A compound inequality is where you say something is more than this, but it's less than this, and we use them a lot. Let me think about. Let's think about the age of people at our high school, students at our high school. Okay, can we say it's just greater than 13? There are some 14-year-olds probably when we first start, right? And then you turn 15, okay, as freshmen. So would you guys say that that's a good enough thing to say? Is just that everybody in our high school is greater than 13 years of age? Does that really describe a high school student? Anybody greater than 13? No? You're not going to have 27-year-olds or 47-year-olds or 87. So what else is there if we think about the age of our students? Less than. They're also less than 19? Okay, less than 19. So we kind of have this range that they fall into, right? And so we have these two things, and let's look at this on the number line. So here's 0. We'll say that's 13, and this is 19. Open circle, probably open circle, I would say just less than. Where are the numbers that are greater than 13 and less than 19? Yeah, they're in this, they're here. Now I'm not going to put arrows on this because it doesn't go forever in one direction or the other. It's just that bit of the number line, just there. Okay? And this is a compound, this is a graph of a compound inequality. And I'm going to actually write it a little bit differently. Since 13's here, 19's here, we always put the small number on the left and the big number on the right, and we put age here in the middle. And I put my two alligators in, and the two alligators always face the same direction. And being alligators, they always want to eat the big number. That's a little elementary to say, but that's the deal. So now let's read this thing, okay? So you start in the middle, and you say A is what? Greater than 30. Why did I say greater than? I came to the big part first, right? A is greater than 13, and this is an and inequality, and A is? Isn't it weird that these can be facing the same way, and you say that one's greater than and that one's less than? It depends on which direction you're reading, doesn't it? Okay, so A is greater than 13 and it is less than 19. So if we pick an age in here like 16, that age is both of those things, isn't it? It's greater than 13 and it is less than 19. And this is called a compound inequality. This one's an and compound inequality. Let's talk about an or. X is less than 3 or X is greater than or equal to 5. Or compound inequalities are always written like this, like two separate things, or in the middle. Let's take a look at this graphically. Here's 0, 1, 2, 3, 4, 5. Let's just graph that one. Open circle or closed circle? Open, good. Up the number line, down the number line? Down. Okay, so like this. Okay, open circle, closed circle? Closed. Up or down? Up. Now I did put arrows on here. So this is what it looks like graphically. And if you think about a number that'll work, like maybe 7, is 7 less than 3 or greater than or equal to 5? It's this part one, isn't it? Is there a number that is less than 3 and greater than or equal to 5? No. It's got to be one or the other, doesn't it? Okay? So this is what an or compound inequality looks like. So graphically, go in opposite directions, and you're going to write two separate inequalities. You're just going to graph both, or write both of them as inequalities, and you're going to put or in between. And then the and, you just put your variable in between the two numbers and put your signs in. What do both alligators always want to do here? Eat the big number. Okay. So let's take a look at solving some of these. Okay. So you're going to be asked to solve a compound inequality that looks like that. Now that might seem like, what? A little bit there for a second, but can we solve that?
Yeah.
You all good with this? What do we do?
Plus the 2 both sides.
Yeah, we add 2 to both sides. Okay. Can we solve this?
Yep.
We add 2 to both sides. So we're actually, what we're going to do is we're going to solve 2 different problems, but we're going to do it kind of all at once. All right. So we're just going to add 2 to everything. X is what?
Greater than -2.
Greater than -2.
Well, less than 5.
And well, don't say but. I know you want to say, like, I think that would actually work, but let's, like, technically we should say X is greater than -2 and less than 5. Okay? You don't have to say X again, but you can say X is less than 5 also. Okay? So this is an and compound inequality. Let's do a little harder one. It's not too much harder though. A few things to worry about on this one. What do you want to do first? -1. There you go. We're going to subtract 1 from each bit. Now remember, we're really solving 2 different problems, aren't we? That makes sense, George? Got 2 different problems, Brian? Yeah? Okay. So -4, this is -2x, and this one's 8. All right, now what?
Divide the 2.
Divide by?
Divide by 2x on
Not 2 by what?
-2.
-2, okay. We're going to divide every term by -2.
And then with both of the sides.
Yes. And then that means if we divide by a negative, both of these have to change direction, don't they? Okay. And when you do this, this is now 2, change direction, 1x, change direction, -4. Do you notice now, where's the big number? And the little number? You notice how they switched? They did the old switcheroony on us, didn't they? And we don't like it that way. We don't like them written this way. We like it written like they are on the number line. So we can flip it. We can put the 2 here, and we can put the -4 here, as long as, do you notice how both alligators want to eat the big number still?
Yes.
As long as they both want to eat that big number, and what about that bit? X is greater than or equal to -4, and X is less than 2. So this is how we want our answer to come out at the end. Okay? You always want to come out with the small number, like on the number line. So small numbers on the left, bigger numbers are always to the right. Correct? That's how we know it's bigger. It's to the right. Okay, so got a piece of paper?
Oh.
Okay. So I'll just make a number line here. And I want you to write a compound inequality that describes this graph. Did you guys use x as the variable, or you can use n, whatever, doesn't matter, whatever variable you like. Probably most of the time we use x, but. So, did you just put the x between the 3 and the 4? Negative 3 and the 4? Right? So the numbers we're looking at here are numbers between those two. So x is some number between them, right? And we know that x is what compared to negative 3? Greater. It's greater than negative 3, and it is what?
Less than 4.
Less than 4 or equal to 4, because of the dot, right? So that's it. You wrote the compound inequality. Should I give you a harder one? This is still easy. Here. There's 2. 6. You try that one? Is this one an and or an or? Or. Okay, so remember, you're going to write two separate things with or in between. Jonah. So you know how to write both of them. Like you know how to write this, don't you? What is x? Less than or equal to. Okay, so x is less than or equal to 2. And then when you graph that bit, x is what?
Greater than.
And can it be less than 2 and greater than 6? No. There is no number that is less than 2 and greater than 6, is it? Okay. So we have to make sure that we say or in that case. And that's it. Okay. Let's solve one. You'll notice in this case, the big number's on the left and the little number's on the right, but don't worry about that at first. Solve it, and then worry about that it's in the right order, the way we like it. Dayton, you doing it? Come on. Pretty easy, Nicole? Cooper? You all good?
Yeah.
What do you say, Peyton? Not a problem?
Too easy.
Too easy? So what'd you guys do to everything? Divided by negative 3. So, you divided by negative. Yeah? So those are going to switch, aren't they? Not the or equal to part. So this is, what is that, negative 8? And this is just 1r now? And this is, so when you actually solve it, do you notice where's the little number? On the left. Where's the big number? On the right. So it's good, right? Both alligators, what are they doing? They're eating the big one, right? They're going after the big one. So we know we're doing it right. We know we're on the right track. Okay, so let's just talk for a second about why we give a crap about compound inequalities, right? So, any of you guys like work on engines or shop? Okay, so on an engine, have any of you ever started a lawnmower and when you first started it, it just like blew smoke out the exhaust, like like black smoke for a few seconds, and then it kind of cleaned up, and you could see it a little bit after that, but not much. Well, the reason that's happening is oil is seeping through the gasket on the what is it called? I lost it. Anyway,
Exhaust.
yeah, it's seeping through. So you have a cylinder. Yeah, it's seeping through the cylinder head here. Okay, so we've got a cylinder like this, and it has this bit in it. It's hooked on. Okay, we won't get too technical about it, but this thing goes up and down. Okay, so this thing slides up and down in this cylinder, and there's a little injector here, and there's a spark plug here, and the injector, it shoots in some gas. This thing comes down and it shoots in some gas, and then what does the spark plug do? Makes a spark, and then what does the gas do? Ignites and blows up, makes an explosion. And when it makes an explosion, what does this thing sliding inside of that cylinder do? Go shooting upward, right? Now this is connected to a shaft, so it goes up and it rotates around, and then it can come back down again, okay? Well, it has to be lubricated, so there's oil up here. Okay, there's always oil up here and along the edges of it. And as it goes down, the oil kind of comes down, but there's a seal. Now what happens if that seal gets worn out? The oil seeps through. The oil gets down into here, and then it burns the oil while you're running the lawnmower. And you don't really see it too much when it's running, but when you first start it, there'll be quite a bit there that seeps through, and it'll burn quite a bit for a few seconds, and then it'll kind of clear out. But if you look at it, you can see it's still seeping through. Well, when we make these things, let's say the diameter is supposed to be 2 inches. Can we make the diameter of the hole in the engine exactly 2 inches? Can we cut it exactly 2 inches? I see Brian saying no way. You can't do that, right? Can you get it close?
Yes.
Okay. Is it okay if it's a little bit bigger than 2 inches?
Yeah.
Yeah. Is it okay if it's a little bit smaller than 2 inches? Yes. Because this gasket is rubber, and it can kind of crush a little bit, and so this usually will say something like plus or minus 0.03 of an inch. Now that's not very much. 0.03 of an inch, that's like the width of your hair. So if we pulled out one of Nicole's hair and held it up, that's about how much variance you have. And if you get bigger than that, if you make the hole in the cylinder head bigger than that, what's the oil going to do? It's going to leak, right? If you make it smaller than that, it might not even go in. Or if it does go in, it might be really tight. And as it goes up and down, because it's so tight, it'll create a lot of friction, a lot of heat. And if it overheats, okay, if the edge of this thing gets really hot, then it will seize. It will like weld itself to the outside. Anybody ever seen an engine that's seized before? Like you can't get it to go. Well, that's what's happening. Is this is actually welding itself in there, usually. Okay. So when we talk about the diameter of this engine, well, it's got to be greater than 1.997 inches. But it's got to be less than 2.003 inches. Maybe we'll do this one. It's got to be in that range, okay? And every single thing we make is that way. When we check to see if a tire, like when they put your wheel on and balance it, can they balance it perfectly? Can they get it in a range?
Yes.
Yeah. Okay. Yeah. Hello. Okay. Hopefully you're checking out. So, this is real life. This is how it goes. I mean, if you think about the rails of a railroad, I guess they're supposed to be like 4 feet apart. Are they ever exactly 4 feet apart?
No.
No. Do you think they could be maybe an inch too wide or an inch too narrow and the train would probably be okay? I don't know. I don't know what it actually has to be. But I'm guessing a half inch or an inch either way, something like that, right? And as long as it's in that area, you're okay. You know? Everything I do, you know, I'm building a house and I take a measurement, and last night I was cutting some boards. They were supposed to be 41 1/4 inches. How many of those do you think I cut 41 1/4 inches? None. Not once. Okay? Now, when I measured them with my measuring tape, did they look 41 1/4, some of them?
Yeah.
But are they perfectly that? Like if we really measured them carefully? Not one. Not a single one was exactly. But did they still fit? Yeah, they still fit. In fact, I was off an 1/8 of an inch on some of them. You know, an 1/8 of an inch too big. And I'm trying to put them in between two things, you know, between two other walls. That just meant I had to smack it with the hammer harder a couple of times, right? A couple of them were a little bit 1/8 too small. That just meant they were kind of loose until I put a couple of nails in them and drove it together a little bit tighter. Okay, so that wall, it varies a little bit, you know. It kind of goes in and out a little bit as it goes down. But when I look down it, does it still look straight? Straight enough. Okay, so that's how humans are. Nothing we do is exactly perfect. We don't do anything perfectly, but we are fantastic at getting it close enough. Okay, that's like the story of my life. Close enough, right? Okay, every motorcycle I ever jumped, did I look like a professional going over that jump? Nope, but close enough because I'm still alive, right? That's my goal, and that's the way life is. Okay, all right. So here we go. We'll talk more about these and use them a little bit more as we go along. But your assignment is chapter 2.5, 1, 2, 3 through 11. No, I lied. 2 through 12, the even. 13 through 17, the odd. 21, 25, and 33 through 40.
You want it?
Yeah, I'll throw it away for you.